In question number 7a, we have the radicals being divided. And so we're going to be able to divide the radicals here since the radicals have the same index. So we're going to do radicals with radicals, numbers with numbers. And we're also going to distribute the division. Now we could try to simplify the numerator and then see if they add together and then simplify first. In this case, although it happens to work out, it's probably better to just distribute the division and see if there's common factors first. So that's what I've done here. I've distributed the division, and we have the term 9 and 432p5 over root 33p4, and the same over here. We can rewrite this with one radical underneath the same radical, so we end up with, in this case here, 9, and under 1 square root, this ends up being 144. I'm just going to move that over. It's going to be 144p all over 11. Okay, so 33 and 432 share a common factor of 3, so we divide that out. We happen to get a perfect square there, which we need to work out. We're going to do the same thing here. We're going to end up with 7 over 27 over 33. They have a share common factor of 3, so we end up with 9p over 11. Okay, and then we can work out the perfect squares. So 9 times 12, and we end up with p over 11 minus 7 times 3, and we end up with p over 11. Okay, those are like terms, so we can actually combine them together. We can also think of them as fractions with a common denominator. When we work this out, we end up with 108 root p over 11 minus 7 times 3 is 21 root p over 11. We can then subtract the 2, so we end up with 87 root p over 11. Now, to get a common denominator, we're going to multiply the top and the bottom by root 11. So root 11 on the top and bottom. So we end up with 87 11p inside the root in the numerator. In the denominator, root 11 times root 11 gives us 11.